right, greetings everyone. Today is September 27th and this is going to be our lesson for today. I'm going to zoom in so you can see it a little bit close. Remember, when you're watching a video, if you need to, you can always pause, you can replay, you can turn on closed caption. All of those things are used to help you be able to make sure that you understand the content. So today's lesson is going to be over linear functions. And the question that you should be able to answer by the time you finish with these notes and a few practice problems is, how can you determine whether a function is linear or nonlinear? Now remember, I am taking a notebook grade to make sure that you have these notes inside of your notebook. Like I said, hit pause if you need to. So I'm going to take you through what's essential to determine whether a function is linear or nonlinear. So we're going to start with vocabulary. Our first vocabulary word is going to be a linear equation in two variables. So it's not actually a word, it is a series of words. So we're going to look at linear equations in two variables, meaning that there's going to be an x and a y. Okay, it is an equation that can be written in the form y equals mx plus b, where m and b are constants. Now, y equals mx plus b, hopefully you remember what that's called. That's the slope-intercept formula. Even if you don't, it's okay. So y equals mx plus b is slope-intercept form, where m and b are constants. Constants are just numbers. It could be any kind of number, positive or negative, a whole number, a fraction, or a decimal. It doesn't matter, but they're just telling you that in that equation, those are going to be numbers. Take a second, pause it, write down that vocabulary term. The next term that we're going to discuss is going to be a linear function. So in order to determine if a function is linear or nonlinear, we got to first know what a linear function is. And a linear function is a function whose graph is a non-vertical line. Remember, with the vertical line test, if a function passes the vertical line test, meaning that it doesn't have for every one x, you can only have one y. Go back and review the notes on discrete or continuous if you need to. But a non-vertical line is horizontal, diagonal. Those are linear functions. And we're going to talk about a few pictures in a minute. So pause the video and also write that down. A linear function is a function whose graph is a non-vertical line. And remember, a vertical line is just a line that goes straight up and down. Okay. Also here, I'm going to make a note that constants are just going to be another word for numbers. And y equals mx plus b off to the side. I'm just making a note for you for later. That's slope-intercept form. And I think that's probably one of my favorite equations. Reason being, it says slope-intercept form, and you get the slope first and then the intercept. So it works. Now, of course, if we determine if we have linear or nonlinear functions, then we got to talk about what a nonlinear function is. Pause the video if you need to write this down. A nonlinear function, it does not have a constant rate of change. Rate of change. What I want you to think about when you see rate of change, the rate of change is nothing more than the slope. Rise over run, change in y over change in x, but a nonlinear function does not have a constant rate of change, whereas a linear function will have a constant rate of change. So I'm going to add that in as well. Give me a second to write that down. To make sure to write that down, but it will have a constant rate of change, a linear function, whereas a nonlinear function does not have a constant rate of change. And what that means is that if it's going to be linear and have a constant rate of change, what you should expect is the same slope. And I'm sorry, I'm trying to squeeze this in. You can always look at Miss Gable notebook if you need to, but on the side, this just says same slope. Over here, nonlinear, if it doesn't have a constant rate of change, then what it's going to have is a different slope. Okay? And if you can squeeze everything in on one page, you go right ahead. Okay? But Miss Gable's going to make it bigger so you can see it. All right? Let's talk about some examples before we go any further. Pause it if you need to write it down. Right, so it's not good until we got all those vocabulary words, but now we got to talk about examples. So for an example, we want to look at if a function is linear or not linear. And this is not the greatest because it's a plastic ruler. But once again, if you have a graph, use what you got. You can use your hand. Pass your hand alongside the function. Now this one happens to be a function, but this one here is a linear function. They both pass the vertical line test from before, so that makes them functions. It just so happened the one on the left is start with a Q. What you think? It's quadratic. That's a quadratic function. It is not linear. And over here on the right, this function here is linear. So I put down the reasons why right here. So the graph is not a line, so it's not linear. Because the word in linear, I hope you caught that, is line. So all your graphs got to be a line. So a graph, the graph on the right is a line. So that makes the graph a linear function. Okay, fair enough. Pause the video so that you can write those things down. Okay, so that's if we have a graph. We got to focus. Moving the paper along as best as I can. Example 2. So for example 2, we have to determine if it's a linear function or not a linear function. And I made 2 separate tables. So the table on the left has x values 3, 6, 9, and 12, and y values 36, 30, 24, and 28. Oop, that shouldn't say 28. That should say 18. I'm sorry about that. Go ahead on and fix it. Pause the video if you need to write this down. But what I'm looking for is my rate of change. It's because if it says it's linear, then it has to have the same rate of change. So going from 3 to 6 is going to be a change of plus 3. From 6 to 9, plus 3. And from 9 to 12, plus 3. Now, on the right-hand side with 36, 30, 24, and 18, we have a difference from 36 to 30, we subtracting, and we subtracting 6. From 30 to 24, subtracting 6. And from 24 to 18, we're subtracting 6. So, I don't want to jump ahead, but what we can see is that on the left side, the right side, we have a rate of change of a negative 6 over 3. So our rate of change, it stayed the same. It was constant. Our slope, that's jumping ahead, is actually 2. But as the x increases by 3, the y decreases by 6. And so the rate of change is constant. So we have a linear function because the x's increase by 3 and the y's decrease by 6. Okay, that would be our reasoning for calling this function a linear function. Okay, on number 2, or the second one, our graph that's going horizontal, we have x values of 1, 3, 5, and 7. So what happens from 1 to 3, we add 2. From 3 to 5, we add 2. 5 to 7, we add 2. However, to go from 2 to 9, we add 11. I'm sorry, 7. Jeez, some Pete's. From 2 to 9, we add 7. From 9 to 20, we add 11. And then from 20 to 35, we add 15. So what happens here, x increase by 2, but the y's increase by different constants. And I'm going to put different, and I'm going to put the word constants. Okay, and it happens to be 7, 11, and 15. And because the constant on the y's are different, the x and y don't have to be different, but this function is going to be a nonlinear function. Now, what I'm going to do is assign you some practice But I want to make sure that you have these notes down. As soon as you finish with the notes, come show Miss Gable, because this will be your credit for today. Make sure you have everything written here as well as everything written on the back. If you need to go back, pause it, rewind it, do what you need to do. That's the bell. But we staying. Ha ha.